Let's continue. If we can compute percent composition from chemical formula, we can also derive the chemical formula of the compound from the given percent composition of its constituents. This usually applies during the chemical analysis, when compound is broken down into its elements to determine its percent composition. So let's have an example. Identify the molecular formula of the compound that was found to contain 40% carbon, 6.71 hydrogen, and 53.29 oxygen. The molar mass of the compound is 60.00 gram per mole. Since the percentages are given, the convenient way to solve the problem is to assume that 100 gram of compound is composed of the elements with masses corresponding to their percentages. This follows that in a known compound, there is 40 gram carbon, 6.71 gram hydrogen, and 53.29 gram oxygen. The masses are then converted to moles. Let's continue. Here are the given values in tabular form. Again, just to emphasize, we assume that 100 gram of compound is composed of the elements with masses corresponding to their percentages. Just like saying 40% of mass of carbon in 100 gram of that unknown compound is 40 gram of carbon, and 6.71% of mass of hydrogen in 100 gram of that unknown compound is equivalent to 6.71 gram of hydrogen, and 53.29% of mass of oxygen in 100 gram of that unknown compound is equivalent to 53.29 gram of oxygen. The atomic mass of carbon is 12 gram per mole. The atomic mass of hydrogen is 1 gram per mole. And the atomic mass of oxygen is 16 gram per mole. And the given molar mass of the compound is 60 gram per mole. In order to determine the chemical formula of that unknown compound, you must follow the following steps. Let's have the first step. Calculate mole of the entities. And to calculate the mole of the entities, just simply divide the given mass with its atomic mass. So for the number of mole of carbon, the mass of carbon is 40 gram divided by 12 gram per mole, which is the atomic mass. Here you can now cancel gram together, and the answer is 3.33 mole. For mole of hydrogen, we have the mass of hydrogen is 6.71 gram divided by 1 gram per mole. So cancel gram together, and you will get 6.71 mole. For mole of oxygen, we have 53.29 gram divided by 16 gram per mole. Cancel gram together, and then the value is 3.33 mole. Next step is calculate mole fraction. Remember that mole fraction can be calculated by dividing the mole of that entity with the smallest mole among the entities. So example, for carbon, we have the mole of carbon is 3.33, and the smallest mole among the entities is also 3.33. So the mole fraction for carbon is 1. You can cancel mole here. For mole fraction hydrogen, we have 6.71 mole divided by the smallest mole of the entities. We have 3.33 mole, so cancel mole again together, and you will get 2. For the mole fraction oxygen, it is equivalent to 3.33 mole divided by 3.33 mole also. Cancel mole and mole. And the mole fraction of oxygen is 1. Now we have step 3. Write the empirical formula of that unknown compound. It is derived from the calculated mole fraction of the entities. For carbon, we have one atom of carbon. For hydrogen, we have two atoms. And for oxygen, we have one atom. So the empirical formula is CH2O. After the derivation of the empirical formula, compute the empirical mass. In computing empirical mass, we follow the same procedure in calculating molar mass. And the empirical formula we have obtained a while back is CH2O. So to compute for the empirical mass, we have to multiply the number of atoms of that particular constituent with its atomic mass. So for carbon, we have one atom of it multiplied by 12, which is the atomic mass, will give you 12 gram per mole. For hydrogen, we have two atoms multiplied by 1, which is the atomic mass of hydrogen, and will give you 2 gram per mole. And for oxygen, we only have one atom multiplied by 16, which is the atomic mass of oxygen, and it will give you 16 gram per mole. Get the sum, and that would be your empirical mass, which is equal to 30 gram per mole. For the fifth and final step, derive the molecular formula by calculating the ratio of molar mass of the compound and its empirical mass with the equation ratio is equal to the given molar mass divided by the empirical mass. And the given molar mass is equal to 60 gram per mole. The empirical mass is 30 gram per mole. So let's substitute the values. Molar mass is 60 gram per mole divided by the empirical mass, which is 30 gram per mole. You can now cancel gram per mole and gram per mole units. And the ratio is equal to 2. And finally, multiply the computed ratio with the subscript of the empirical formula. So, for carbon, we have one atom of it in the empirical formula multiplied by the computed ratio, which is 2. So that would be 1 multiplied by 2 will give you 2 atoms of carbon. For hydrogen, we have 2 atoms in the empirical formula multiplied by 2, which is the ratio, will give you 4 atoms of hydrogen. And lastly, for oxygen, we have 1 atom in the empirical formula multiplied by 2, which is the ratio, will give you 2 atoms of oxygen. Therefore, the molecular formula of that unknown compound is C2H4O2. It is also known as acetic acid. And we're done. I hope that you were able to follow the 5 simple steps.